The universe is everything that we can observe, from the smallest particles to the largest stars, and even the vast galaxies and galaxy clusters. It includes invisible dark matter and dark energy as well. The scale of the universe is incredible and filled with mysteries. Throughout history, humans have been exploring the origins of the universe and proposing various theories to explain it. However, the most widely accepted explanation is the Big Bang Theory. According to the Big Bang Theory, our universe began as a hot and infinitely dense point about 13.8 billion years ago. This dense point then exploded, creating matter, energy, space, and time. The early universe went through two main stages of evolution: the radiation era and the matter era. After the Big Bang, the universe entered the radiation era, where radiation dominated for several thousand years. The radiation era consisted of several smaller stages. The first stage was the Planck epoch, which lasted from 0 to 1043 seconds. During this extremely brief period, the universe existed only as energy, and the four fundamental forces of nature were unified. When the Planck epoch ended, gravity separated from the other three forces. The universe then entered the inflationary epoch, during which it rapidly expanded. The inflation lasted only 10 to 4 33 seconds, but increased the size of the universe by a factor of 10^30. During this stage, the strong nuclear force separated, and energy began to convert into matter, forming a period dominated by quarks. Next, the universe entered the electroweak epoch, where the electromagnetic force and weak force started to separate. Protons and neutrons formed, and after the universe cooled down at 0.01 seconds after the Big Bang, photons, electrons, and neutrinos were formed. The universe then entered the nucleosynthesis epoch, during which protons and neutrons fused to form atomic nuclei. This stage marked the end of the radiation era. After the radiation era, the universe entered the matter era, where matter dominated in the universe. The matter era can be divided into three stages. The first stage is the atomic epoch, which occurred 300,000 years after the Big Bang, when the universe cooled down to 3,000 degrees. At this temperature, electrons attached to atomic nuclei, making the universe transparent, and photons could finally travel through space. The second stage is the stellar epoch. With the formation of a large number of atomic nuclei, gravity started to take effect and gradually condensed them into gas nebulae. As gas nebulae appeared, gravity caused them to gather and, during the process, formed a high-density sphere. As more and more matter accumulated in the sphere, temperature and pressure increased. Eventually, when the temperature reached millions of degrees, hydrogen ignited, resulting in a thermonuclear reaction. This is when the first batch of stars in the universe began to form. The last stage is the galaxy epoch. After a significant number of stars formed, their formation triggered a chain reaction. They grouped together to form smaller star clusters, which then merged with other star clusters, gradually forming larger galaxies. Over time, as stars died and were reborn, and as galaxies collided and merged, everything we see today was created. This is the process of the universe's evolution. Although it is only a theoretical speculation, it is the most widely accepted hypothesis in the scientific community regarding the origin of the universe.